In this video, we're going to discuss using MyoMotion 3D motion capture. So this is an IMU wearable sensor that you can add to your force plates or EMG analysis. So first, I'm going to look at cutting maneuvers utilizing the force plate, the high-speed video, the 9aux 125 cameras, as well as the motion capture system. So I'm going to get rid of our lateral cam and just observe our frontal motion. So in this record, the person is doing a frontal cut as well as a lateral cut, so anterior versus lateral cut. We just have 7 sensors on the lower body, so from the pelvis down to the feet. And this is giving us 3 axes at each joint. So we have our X, Y, and Z axes. So for this, it would be flexion, abduction, and rotation of the hip, as well as the knee. And for the ankle, it would be inversion, dorsiflexion, and abduction. Now, all of the sensors can be placed on other parts of the body and can be defined otherwise. So if you have 7 sensors, you can redefine them and put them on the upper body as well. I'll show you what that looks like in a minute. Let's just take a look at our anatomical data though. So as soon as you put them on, you have a 10-second calibration, and instantly you're going to be able to look at your anatomical angles. All of these angles are live. So you can do a biofeedback if you want to make sure someone is getting to a certain depth on a squat, or if they are landing appropriately. We know that from drop jumps, if there's landing and they don't go into enough knee flexion, that it is a risk for ACL injury. So there's just a couple of things that you can look at and actually just decipher away from all of the data. So if you just wanted to look at the knee flexion, you could just have that scale up and just be looking at that parameter and set certain thresholds on that as well. So that's it using for a biofeedback or training tool. As far as an analysis tool, there are different reports that you can run on all of this data as well. In the other tab, we have our orientation angles. This is just the segment orientation in space. So the pitch, course, and roll of each of the segments. The one that's most used is the pelvic pitch. That would be the anterior and posterior pelvic tilt. So this is helpful if you're doing anything with bike fitting, if you're in a squat and you want to look at any hyperextension or flexion of the lumbar, and if it's being caused by that pelvis being in a posterior anterior position, you can take a look and really understand what's causing certain movement patterns. And then you have your accelerations as well from the IMU device. Now this can be helpful just to observe impact acceleration. So from a jump or landing technique, you can look at the impacts up the chain, so from the feet all the way up to the pelvis. However, the other thing that you can observe is actual bar speed or bar acceleration. So you can have an extra sensor and place that sensor on the bar and have the acceleration data of the bar. So if you're doing a squat or a deadlift or a clean, you can observe that acceleration along with your own body accelerations. So let's take a look at a couple of other demo records here. So let's observe just a normal treadmill. So in this case, the person is just walking on a treadmill at a very slow or average rate. We can look at the anatomical angles since it's a cyclical event. We can look at them in a very quick report, and same thing can be done for cycling or any other cyclic event like a squat. So we have our accelerations on the feet, and so we can actually make those accelerations into foot switches. So we can actually look at each foot stance and swing phase, so for the left and right feet, based off of the accelerations here. And now that's just an automatic example. So if you wanted to run a report, you would go to report and you can click on for the motion capture, just a gait foot switch report. Now this is going to break down your movement pattern into the stance and swing phase. Whoops. So you can select the channels of data that you want to observe. So in a institute of sport or in a physical therapy office or a gym, there may be only a couple of parameters that you want to look at. You only want to see hip flexion, hip abduction, and pelvic motion. You could select just those things. You don't have to have everything within your report. So I'm just going to have these selected for now and say next. And then because we had our contacts, our foot switches on our IMUs, it automatically found our stance and swing phase for both the left and right side. So I'm going to say next and instantly get a report. Now this is a gait report for both running and walking. The only normalized data in this system is going to be for gait. There's no squat normalization yet, but you can always make your own normalized database. So in this, we have our gait phase parameters and the stance phase through the double stance phase, and just comparisons of the left and right side, their differences, and then the normalized data is in the green box. The gait spatial parameters, now these will only work if you know the total distance that that person has actually traveled. So that's just something to note. Right now it's set at a fixed travel distance of 10 meters, so these may not be an accurate measurement. However, if you set your record up to a 10-meter walkway, then you could make sure that this data is accurate. You also have your gait time parameters, so step time, stride time, and cadence. And then down here we have our anatomical data. So this is our left and right side comparison. The first phase here is our stance, and the second phase is our swing. That dark line is going to be your average of each step, and then the shaded area beyond that dark line is the standard deviation. So you might notice on the left side, there's definitely more deviation in each of the steps versus his right side. That's just something that you can take a look at and quickly observe. And if you want to go into a further analysis, you can do that. Then we have our amplitude parameters, pretty much just the minimum and maximum degrees as well as the range of motion. But you can always change this report and add in a large scale of different options. And I would work with whoever is working on this report to develop the best set of parameters that you want to observe so that you can always choose the same thing and have just it be a part of your battery of testing. So let's go back to another record. And we'll just go to a quick parkour type of running and cutting. This is just someone doing a bunch of different cuts, and they have the motion capture system on and also a pressure insoles as well. We'll just take that out for the time being. Now this is just so you can observe a full body system, and this person is moving rather quickly, and it's keeping up with the IMUs are keeping up with that movement. So this is capturing at 200 hertz, and because we have all of them here, it's difficult to see all of the data, but you're able to observe all of the anatomical angles in this section. Now, just so you know, down here we have our tibialis and gastroc. Those are actually EMG sensors as well. So the system can be built up to an EMG, force plate, motion, and pressure type of assessment. However, usually when you're doing a sporting analysis, you want to be able to run through a bunch of athletes rather quickly and get report right away. So you want to try and limit the amount of data that you're going to collect. And so I would suggest using a lower body system. If you're doing a throwing, then you could just make it just upper body. Using a camera is nice to have that reference video along with your avatar. And then if you want a really quick measurement with no setup at all, you would use force plates. And then the last thing I'll show you is just another report here. And this is just going over what it would look like for a very simple flexion extension, eccentric, concentric type of exercise. So they're just going to do a bilateral squat. Very simple exercise, but what we can do now is just do an average curve. So break it up into motion report, average curves, breaking it up into those two different areas. So again, you select the channels that you want to observe. So in this case, if you want to look at the thoracic and lumbar flexion, and what the hips and knees are doing, you can select those. And then you want to select every interval with event. So this just means that you have your up, down. So that is the beginning. That is the bottom of the squat. And this is the top of the squat. And then you say next. And so now you have your left and right side anatomical angles, and you have your, you can actually change this from pre-event and post-event to eccentric or concentric or up-down or down-up phase. These are relative to the 100% of the total phase. So if it's one squat, the top of the squat would be 100%, and about the other 50 or 60% would be the turnaround, so the mid-range. So you can observe any differences between the bilateral sides, or you can look at just that standard deviation again and notice if they're inconsistent with their squatting or flexion extension of any other movement pattern. So those are just a few examples of how the motion capture system is used.